Hello, everyone. Welcome to the AI Agents Hackathon live streams.
The AI Agents Hackathon is a free virtual hackathon running from April 8th to April 30th.
We're hosting over 20 live streams where you'll learn how to build agents using various Microsoft technologies. At the end of the 3 weeks, submit your project for a chance to win fantastic prizes.
And now over to our friends at Reactor.
Hi, everyone. Thanks for joining us for the AI Agent Hack. Before we start, I do have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is recorded. It will be available to view on demand within 24 to 48 hours. With that, I'd love to turn it over to our speakers for today. Thanks for joining.
All righty. Hey, everyone. How you doing? My name's Farzad Sanavala. I'm a principal product manager working on Azure AI Search. And here for today's Agent Hack session, we're going to be talking about mastering Agentic RAG. And so some prerequisites are going to be, hey, just what in the world is RAG? But don't worry, I'll walk you through. I'm probably only going to spend like 1% of the next hour on actual slide content because this is a mastering agentic RAG. Personally, I feel that being hands-on is the best way to actually learn new concepts. And so I have a bunch of different code samples, some actual real-world scenarios where some customers are actually using Agentic RAG, and I'm going to show you exactly how you go from 0 to 1 building an Agentic RAG system. And we're going to talk about different tools and different frameworks. We'll talk about Azure AI Agent Service. We'll talk about Azure AI Search, of course, kind of the best product out there. We'll talk about Azure OpenAI Service. We'll talk about Semantic Kernel. For those of you who've heard of Semantic Kernel, Llama Index, Crew AI. I'm going to throw a whole bunch of different tools and frameworks at you because at the end of the day, this is all about learning. It's all about getting your hands dirty. And the best way to do that is getting hands-on. And so with that, I'm just going to move to the next slide here. Yep, as I said, my name is Farzad. I work on the Azure AI Search product team. If you want to follow along all the GitHub code samples, everything is going to be posted for you. I'll drop everything in the chat as well. If not, if you want to go directly to my GitHub and see all the goodies that we're talking about, it's Farzad528. Additionally, on the previous slide, I also blog a lot on Hashnode. So everything you can see here, for the most part, the bet for me personally, I love blogging. I think it's a good way for me to storytell exactly what I've learned. So anytime I interact with a friend or a customer, or I just want to learn something on my own, I'll go read up about it. I'll implement something hands-on as an AI developer or AI enthusiast or practitioner. And then I like to blog about it to make sure that, I've had a good, solid foundational understanding of whatever concept I'm trying to learn. All right. So what in the world is Agentic RAG? I'm going to give you 4 bullet points, and then we're honestly just going to jump into some code. So when someone talks about Agentic RAG, the first thing you should probably think about is what is RAG in general? And so a good high-level overview of what RAG really is Retrieval Augmented Generation. I'll just give you the one-liner. Essentially, if you want to interact with LLMs or large language models, one of the biggest limitations of LLMs is one, they have pre-trained data sets that have a knowledge cutoff. Okay, so all these LLMs that are coming out, they have a pre-trained knowledge up to a certain date, and most likely it won't be today's date. Okay, and so when you try and interact with these large language models, trying to ask something very, recent on, as of April 16th, a lot of times you won't get an answer unless it has some agentic capabilities or tool calling capabilities. And we'll talk about that. And the other is if you want to interact with a large language model, but over your own private data or your own knowledge base, right? And so obviously when you're talking to OpenAI GPT-4.1 as of recent, you can't, it doesn't have any knowledge of your organization's data. It doesn't have any knowledge of your private data, like your Outlook, your WhatsApp messages, whatever it might be, of course, or at least we hope not. It doesn't have access to all that data, right? And so in this case, RAG is the technique or pattern that you can use to give context of your private knowledge to large language models. And that opens up a world of possible scenarios in the field of generative AI. And so when we talk about the RAG framework, usually it's kind of split into a data pre-processing or ingestion pipeline, getting your data into a retrieval system or a vector database or vector index, whatever you want to call it. And then once you ingest that data into a nice retrieval system or a search engine, recommend Azure AI Search for that if you're using building agents on Azure. You want to get your data into that retrieval system, and then you want to start querying that retrieval system, right? And so when you query that retrieval system, it's really important that you type in queries based upon the task that you're trying to solve. And if you have a very robust retrieval system, you want to make sure that you're optimizing to have your best results always at the top, right? Because at the end of the day, there's a concept called context windows when you interact with majority of large language models, and there's only a certain amount of context that you can ground or shove in to a large language model input, right? And so querying a retrieval system is very, very important, and you want to make sure you have a retrieval system that can almost always give you the number one ground truth result at the top position, okay? And so then once you have kind of that general ingestion and general query strategy, just like a regular, search engine like Bing, then you want to start doing some agent integration. And so what does this mean? When someone starts creating an agent, I'm going to go back to this next slide because I think that's important. So at the end of the day, this hackathon is about building agents. And so RAG is absolutely critical for building an agent system, because when you build an agent, you usually have a certain task that you want it to solve. And so the core components of an agent in reality is a language model, usually some sort of tools, and then some sort of planning for deciding how the model should orchestrate calling these tools. And then you could even get even more advanced in terms of agentic RAG, where you may have a tool that performs RAG, like an Azure AI Search tool, and we'll show that in a bit. It'll go and retrieve some documents for whatever task your agent is trying to solve, whether it's an agent autonomously querying or a multi-agent system doing some maker-checker patterns, talking to each other in a group chat, or maybe it's just a single-turn agent where a human is just interacting with maybe a chatbot, for example, to go and retrieve some sort of information, then maybe do an action like send an email or a phone call that I think we've seen in some previous sessions at the Agent Hack. And so when it comes to agentic RAG, imagine this tool, this Azure AI Search tool, can autonomously go and reflect and plan, rewrite queries, or maybe the agent itself can go and intelligently, over a series of different iterations and turns, go through these different tools that it has at its disposal until the language model or agent feels satisfied that this is the correct level of information I want to get. Okay, so in a nutshell, that's all agentic RAG is inside of using the conventional or traditional RAG framework, but in an agentic manner. Okay, so think about reflection, think about planning, think about iterative querying, think about leveraging other tools to make that traditional RAG process even better. So there's advanced techniques like, I won't be showing this today, but like corrective RAG, self-adaptive RAG, and so on. The list of Agentic RAG frameworks go on. But today we're going to keep it somewhat basic in a Mastering Agentic RAG session for this RAG hack, but we'll provide a whole bunch of resources where you can go and learn more about some of these more advanced Agentic RAG strategies, as well as some future sessions inside of this agent hack. Okay, so one of the concepts of Agentic RAG that I want to talk about today is called memory. Memory was one bullet on that other slide, but I didn't spend too much time on it. And it could probably have a whole 1 hour session or maybe a whole hackathon dedicated to just memory. Okay, so memory is important when it comes to building agentic RAG systems or just agents in general, because at the end of the day, you want your agent to be as intelligent as the human brain. And what are the kind of the core concepts or fundamentals of a human brain? The ability to memorize information and the ability to recall it when needed, right? And so when you build AI agents, incorporating memory in some way, shape, or form can be extremely useful. And so in this code example, I'm going to show you how you can use an open source framework called MEM0, and how you can use Azure AI Search as well as Azure OpenAI for automatically managing memories. And so this means when you interact with an agent or a model, the system will automatically take your raw chat history and at runtime and distill it into facts. And these facts can be, whatever a fact means to you. It could be things just like entity extraction, like work-related things, personal preferences, travel plans, and your relationships with people, whatever it might be. But those are all things that are, probably important to have inside of memory. Okay. And so with that being said, I'm going to jump into the first demo. Okay. And we're going to talk very briefly about memory and the importance this has in kind of overall agentic RAG systems. Okay. And then we'll go quite deep into more more business-oriented use cases when it comes to building AI agents. Okay, so with that, I'm going to open up Visual Studio Code over here. And so I have a bunch of repos here. This one I'm just going to make a little tad bit bigger. And the first thing I'm going to show is, which repo is it? There we go. So in this repo, I have my Azure AI Agents Playground, okay? And so what I'm going to do is I'm just briefly going to walk through this Jupyter notebook, okay? And so inside of this notebook over here, it shows you how to use MEM0 with Azure AI Search and Azure OpenAI, okay? And so step one is pip install MEM0 AI, okay? And I have some environment variables saved over here that I'm going to be using for my MEM0 integration, okay? And so if you don't already have these, you can get these endpoints and API keys, or managed identity is preferred to be extra secure for using or reproducing this Jupyter notebook. Okay, so in this case, I went to the Azure AI Foundry and I went ahead and deployed an Azure OpenAI model for chat completion. You could use whatever you want. In this case, I'm going to use GPT-4o Mini. I'm also going to use Azure AI Search for managing the memories. So I'm not just using AI Search, kind of for those of you who've heard of the product before, which I'm sure you probably have because it's so awesome, for conventional kind of knowledge retrieval or keyword search or vector search. I'm going to actually use it when I'm interacting just with an agent that I'm not actually giving any knowledge to. I'm just going to interact with a single turn agent with no knowledge tools. And I want MEM0 to manage the memory, memorization of memories, of facts, and then recalling them when needed, okay? And so in this next code block, I'm just gonna show, you can see here, I'm loading the environment variables. Inside of MEM0, you could follow along on the documentation as well. There's a memory config. So you can see here what I'm passing. I have a collection name or index name that I'm going to call memories. And then you can see over here, I have embedder. So why do I need an embedder? So when you build a memory layer or a memory system in this case, which is just going to distill facts as a function of raw chat history, what this is going to do is it's going to go ahead and distill some facts, and it's going to go ahead and vectorize those and store them as a sentence. And then it's going to vectorize them using this embedding model. And then it's going to do a vector search every single time I chat with my agent to go see, when Farzad's asking something, it's going to do a vector search and try and retrieve whatever relevant memories that Farzad has. Okay. So then I have my LLM. I configured this above. I'm going to initialize my memory. And so this is just more of a basic example where, I'm explicitly showing like, if I wanted to do a demo on memory, here's demo user. I want to add a specific memory. So they have utility or methods here on the memory initialization that says, hey, this is the memory I want to add, and this is the user ID. So why do I need this user ID? Because think about when you're interacting with ChatGPT, at the end of the day, everyone has their own user ID, because I don't want to go, interfere with Pamela's memories when she's interacting with ChatGPT. They could be very personal or very confidential information. So having that user ID here is really important. And later, when it comes to, building memory systems at scale, the reason why this is so important is because you could then filter by user ID. If you're building this for, an agent for a variety of different customers, maybe millions of customers, okay? And so you can see here, I'm going to print that. And in this case, I'm just adding a conversation to showcase how the memory actually works. I'm adding memory with metadata. So metadata here is really powerful as well, because for those of you who have used AI search before or retrieval systems, having metadata is probably one of the most powerful things you can do. And in the world of large language models, being able to utilize that for metadata creation is again very, very powerful, because in an agentic RAG system, when we talk about some of the agentic strategies, being able to query rewrite an AI search request payload is very, very important, because one of the best things you could do is give context of what your AI search index schema looks like. And if you have filterable fields that are metadata like category, your agent can be intelligent enough to write a filter clause. And when you filter correctly, at least, that improves recall, because you're filtering on something to make sure that you have the best candidate set of retrieved information. And this holds true both for memories and for conventional knowledge retrieval. Okay, so you can see here, I'm just searching some memories. So in this case, I talked about some travel plans. I have metadata for travel preferences. I went ahead and click import into medium. Maybe the language model will pay attention to some of these metadata and prioritize it. If you want to get really fancy, you could use scoring profiles in AI search, but I'm not going to do that right now. Inside of this search results, you can see memory.search. I'm going to ask what are this user's travel plans, pass in the user ID, which is just Farzad, or demo user in this case, and then the limit property from mem0, which is essentially the same as top in AI search, which just means 3. Okay, so now I'm going to search for memories. And then I also have a function for getting all the memories, because I think that's also cool. So you can see here, mem0 is initialized. Here's me storing memories. Here's me searching memories, and you can see these scores here. How am I getting these scores? Because we're doing a vector search, okay? And because I'm using Azure OpenAI embeddings, I went ahead when this index was created as part of the integration with mem0, it's going ahead and putting a cosine distance. So it's calculating the cosine similarity from the search that's actually being done, which talks about user travel plans, to the memories that I have inside of my AI search index or memory index. And then also, if you want to see all the different memories, here's the total amount of memories. So that's kind of a basic example of mem0. And so what I'm going to do now, I'm actually going to show a UI version Okay, so in this case, imagine you just implemented this in a production environment. Maybe I should have started with this, but that's okay. So we're going to jump into the Mem0 playground. And I think this is really, really cool just to really demo just the art of the possible when it comes to memories. So just look on the right-hand side here. It says your memories, okay? And so I'm going to say something like, hey, my name is Farzad, and I'm a PM at Microsoft. And I'm so excited to talk about memory, Agentic RAG, and other cool AI agent stuff at Agent Hack. And so I'm going to interact with my language model here, okay? And so there's a system prompt in the backend. And so here I get GPT-4o talking back to me and says, hey, great, you're excited about memory agentic RAG. Cool, cool, cool. Awesome, awesome, awesome. Boom. Did you see this thing that happened on the right-hand side right here? These memories were extracted from my interaction with this agent. And so these distilled facts, it says, is excited to talk about memory, is a PM at Microsoft. And so maybe you can say, I am based in Texas. Oh, whoops! I don't know how to spell today. So let's actually try this. Let's see if it gives a fact. Oh, okay, it auto-corrected to Texas, so that's good. But you can see here inside of the relevant memories, it actually did a vector retrieval. And so if I click into here, you can see that it did a memory retrieval step. Okay, let's actually try that. Let's try that again. But let's actually do something. Just kidding. I moved from Texas to New York City yesterday. And so memory CRUD is really important here because the last thing I want is my memory management system and my agent saying that I still live in Texas. So if you saw here, it actually updated that is from Texas to move from Texas to New York City yesterday. And so, it's asking me about how everything's going and so on. And so these are just some examples of how memory actually works. And so you can get really fancy and create memory over all your different threads that you have with an agent, just retaining the chat history within a single thread is also really important, and so on. And so this is important concept when it comes to agentic RAG. Because at the end of the day, whatever concepts you can help your AI agent with to improve the outcome, in most cases, probably response quality or business value, whatever you want to call it, is going to be absolutely critical as an AI agent builder. Okay, so with that, I'm going to speed up here just because there's a lot I want to show you. So I'm just going to quickly go through this. So here's another code example. There's a lot of different code here, but I wanted to quickly show it in action to show the different types of memory using Mem0. So I have a travel planning assistant over here, kind of a little bit more real world scenario where I have my memory config. I have some functions here. So this is actually, instead of manually in the basic example, adding memories and adding a conversation history, it's actually a real world conversation where I'm leveraging a large language model to actually do the memory management CRUD, or essentially the create, read, update, and delete operations on my data. Okay, and so that's exactly what it's doing here. I have a system prompt. We all know what a system prompt is. I have a query and then memory text that I'm actually going to pass in. Here's my response using Azure OpenAI chat completions and so on. I also have a verification of a memory step as well, just to showcase here. So I talk about I'm planning a business trip to London for about 5 days. I want fish and chips because I love fish and chips near London Bridge and so on. And so you can see here the travel planning assistant results. It actually includes memories in the context. And so on every single turn of this conversation, you could actually see what the relevant memories are, just like the UI demo I showed. So highly, highly recommend checking out Mem0 and incorporating memory into your agentic RAG applications. Cool. All right. So we talked about memory. I'm now going to quickly jump to another topic, which is going to be agentic RAG single step reflection. Actually, just for time's sake, I'm actually going to go to agentic RAG multi-step reflection, and I'll show the single step. But they're very, very related concepts. Think of one as kind of a starter agentic RAG strategy, and then the multi-step reflection is kind of a little bit more of an advanced strategy. And so in this use case, I'm actually going to show a real world example. Okay. And so just for context, a buddy of mine is actually a real cardiologist, okay, a practicing cardiologist. And he actually mentioned that, hey, I'm into AI. I want to use AI in my work. And so as a cardiologist, I asked him about, hey, so how do you want to use AI? What do you actually use it for inside of your day to day? And he said, well, when a patient comes in, comes in for a visit, a lot of times as a cardiologist, there's tools that he has as at his disposal to go and make an informed patient recommendation. Okay. And so these tools consist of a patient medical records. So hopefully we've all been to the doctor. And so your doctor has your patient medical history. Okay. Oftentimes, this is very stored in a very structured manner. It'll show your medications and so on, how many times you've visited, your ancestral history and stuff like that, and so on. And then also, because it's a very specialized field in cardiology, there's a set of guidelines called the American College of Cardiology Guidelines. And inside of these guidelines, which is just unstructured data, if you're a practicing cardiologist and a member of this association, it's actually, I think there's some information open on the public web at the ACC website where it just has a bunch of clinical trial information, a lot of PDFs, a lot of kind of standard operating procedures, best practices, studies, and things like that. Okay. And so these are unstructured data with PDFs, charts, and so on. And so then the other thing he also mentioned he uses is web search. And so maybe the FDA just in the US, the Food and Drug Administration just may have released a very cutting edge medication that could save someone who just had a very life-threatening heart disease. And it just got approved yesterday. And so maybe he could use the web to get that information very quickly. And so in this case, what we're going to do is we're going to build a multi-step agentic RAG process. And this is kind of going to go through a little bit faster than some of the basic agentic RAG processes. But I think when it comes to generally building kind of agents, a lot of times your agents are going to need different tools. And so in this example, I'm going to show you a real forked from a real world example. All the data here, the structured data here, the patient history is going to be completely fabricated, completely made up, but very, very similar to the schema of what a real doctor will have. Okay. So over here, you can see I have a structured data. I have data inside of an Azure SQL database. This is my patient records. In Azure AI Search, I went ahead and created a vector index. Everyone should know now how to create a vector index. If not, so many great resources on it. But you could literally do it in just a few steps with no code if you have data in an existing Azure data source like Blob Storage, for example, or Fabric OneLake. And then we're also going to use Azure AI Agent Service with Bing grounding for web data. Okay. And so we're going to have our agent federate a bunch of different data sources, okay, from structured to unstructured to live web search, okay? Now, this is really, really powerful when it comes to building agents because you're incorporating all different types of data modalities and structures inside of a single natural language interface, okay? And so I'm going to walk through this very carefully. And so in this Jupyter notebook over here, I'm using Azure OpenAI's function tool calling capabilities, okay? So there's a lot of different tools that you could use, a lot of different frameworks or products or services you can use. And you could use Azure AI Agent Service for managing the tool calling. You could use the OpenAI SDK. You could use Semantic Kernel. You could use LangChain. You could use Llama Index. But just like I said earlier, at the end of the day, I wanted to do something to help create customer value. And as a practitioner and AI enthusiast, I was very familiar with the existing OpenAI function calling and tool calling. And so this was the fastest time for me at the time of writing this notebook for building an AI agent. Now that I know more, I would probably refactor this to make it a little bit more enterprise ready, a little bit more capabilities that now that I know that Azure AI Foundry has. And so I'll talk about what I would do as next steps to refactor this or how you can just use this as is today and still create a lot of customer value. Okay. So first step, I have a requirements.txt file over here. So I'm just going to go ahead and open this up. I think I'm in query transformations. I have, query planning. I have a bunch of different requirements that I'm using. So yeah, I'm not going to go through SQL operations. I'm using Azure OpenAI Client SDK. I'm using Azure AI Projects SDK. I think that's it, to be honest. So with that, I'm going to import some libraries. So over here, you can see SQL Alchemy, PyODBC for doing some SQL operations. I am going ahead and also using Rich just for some UI displays, but I'll actually jump to a UI demo for this because I think it's a little bit cooler. So yeah, so in this case, I'm actually using Azure OpenAI models. I'm using Azure AI Search, and then I'm using Azure AI Projects or Azure AI Agent Service for getting my Bing grounding tool. So if you want to use Bing Web Search, highly recommend provisioning an Azure AI Agent Service and invoking the Bing grounding tool. Very, very cool if you want to use web search capabilities on Azure. And then I also have an Azure SQL database. This could be any structured database, could be SQLite, it could be Fabric OneLake tables, which is just a SQL Server analytics under the hood. In this case, again, probably you want to use managed identity for privacy and security. In this case, I'm just going to use username and password. You can see here how I'm creating my connection string, going ahead and initializing the OpenAI client. Okay. And so the reason why I think this is important to kind of build tool calling agents from scratch is because at the end of the day, mastering tool calling that's gonna be what makes you a master to Agentic RAG. Say one more time, mastering tool calling is going to be the thing that makes you a master at Agentic RAG. Okay. And so understanding how different models, in this case, I'm going to use OpenAI GPT 4.0, understanding how different models support tool calling or function calling invocations are extremely, extremely important in the AI agent world. These tools are going to be the thing that create exponential value. Okay. And there's, lots of things going on with like MCP and things like that to make, tools a lot more friendly to use and standardize and so on. But when I like getting started from scratch, I like, using the most very minimal abstractions and frameworks to make sure that as an AI developer, I really understand what is going on under the hood. And once you understand what's going on under the hood, then you can go crazy, vibe coding and using Copilot and all these abstractions and things like that to build agents, maybe all in natural language or in very, very minimal lines of code. Okay. But when things perhaps stop not going well, then you might struggle on where to debug if you start from there. Okay, just my personal opinion as a best practice. But anyways, I digress. So talk about unstructured data. So the first tool I want to build is a Search ACC, American College of Cardiology Guidelines. Okay, so I'm creating this function. Here's my doc string. I already have a AI search index created called ACC. And I'm going ahead and authenticating using the AI search client. So yeah, in this example, I'm also using the Azure Search Documents Client SDK. You can see over here, I'm calling the search method. We love our vector search, or in this case, a hybrid search. In this case, actually a hybrid plus semantic search. And so if you don't know what those are, highly recommend reading some of our blogs. If someone in the chat wants to post a link to learn more about hybrid plus semantic search, awesome. Highly recommend reading into it because I told you having the best possible retrieval system to get you the best results. In this case, it could save someone's life by returning the best documents to help the cardiologist give the patient the correct information. So I have a vectorizable text query. I'm passing in a the raw user query for whatever the agent may write over here. My k nearest neighbors is going to be 10. So essentially just my 10 chunks of my PDFs. And then I have a field called embedding to actually do the vector search on, query type, hybrid plus semantic, because I want the benefit of the re-ranking. And so on. So with that, here's just a loop to loop through my results and concatenate it all in a chunk field. And here's my context string. So if it gets things, it's going to put it over here from AI search in this context string, or otherwise it's just going to say no guidelines found. Okay. Second up, we're going to have a web data tool. Okay. And so this is going to be for how you can search the World Wide Web. Okay. So in this case, I'm going to use the Bing grounding tool. Very simple to use. The only prerequisite is you have an existing Azure AI Foundry project. So if you don't know how to use that, I recommend going to documentation. You can deploy an AI Foundry resource and get deploy the Bing grounding tool as knowledge. And once you are there, you can go ahead and create an agent. So in this case, I'm having kind of an agent tool call an agent strictly for the purpose of Bing web grounding. Is that the most efficient way to do things? Probably not. But for kicking the tires, this was a good MVP start to creating some sort of business value. Okay, so in this case, I'm using the Azure AI Agent service, creating this temporary Bing agent that its sole job is just to have a tool that is an agent in this case that will go and return results from Microsoft Bing search. Okay. So perform a search and return the results directly. Cool. In this case, just like you saw in Mem0, I'm creating these chat sessions, or otherwise known as threads. I'm creating these threads, creating a message, and running the agent through this message called create and process run. Okay. And so in this case, I have a single thread ID, which is the existing thread that I'm actually chatting with, and then my agent ID over here. Okay. And then I'm not going to go through all this code, but essentially just some extraction of the actual agent to get it into the format that I actually want, and so on. Okay, so that's the AI agent service. There's a lot more simpler ways of calling the Bing grounding tool natively and using the Azure AI agent service directly. But for now, we're going to use that as the tool. Okay, so over here, we have the lookup patient data tool. Okay, and so in this case, I have data inside of Azure SQL. And actually, I think I have a script somewhere here that actually shows how I think when you build demos, it's always used to, usually have a fake patient with the real table schema that I want. So if anyone wants to use Azure SQL, so honestly, one of my favorite products in Azure, and use PyODBC or SQL Alchemy to upsert data into this database using Faker. Here's a script that you could run to upsert some data over here. So cool, just a little FYI. But imagine real life, this would be connected to like a real patient management system. Okay. And so in that case, if that patient management system had an API, this could just be a REST call to a function call to that source system to go and retrieve information. Okay, but in this case, it's structured data, so we need to do some natural language to SQL. Very complex topic in the AI world, but we're going to do it. Okay, so in this case, inside of this function, this lookup patient data function, this is what we're doing. I'm being very explicit. You'll see later when I actually configure these tools for my agent. I have patient medical data. I have essentially saying I'm using SQL Alchemy to create this engine, and so on. So here's just using the SQL Alchemy package to actually create the engine. Using personally, I don't think you have to use a pandas data frame, but I thought it was a little bit easier to do kind of operations. I think you also get some performance benefit from it as well. And you can read this pandas data frame in SQL and so on. And so now that I defined all my tools, I'm just going to pick up the page just a little bit here. I have now my tool calling array. Okay, so inside of this tool calling array, what am I doing? Okay, the reason why you hear tools and function calling kind of interchangeably is primarily because of this. So I know I have a bunch of tools for my agent, but what are these tools really? They're functions. Okay, so I have a tool of type function. What is my first function? It's what I defined above, the search ACC guidelines. What is that searching? My Azure AI Search index that has all of these parsed PDFs and vectorized and so on. Okay, so what is this description? This description is so important because your agent's actually going to reference these. And so it has to know what you want this function to do. So in this case, I'm saying query the ACC guidelines for official cardiology recommendations. Use keywords related to cardiology conditions, treatments, or guidelines. Okay. Then I have parameters. So here's a type object. Here's the properties that I want. And so this is another topic called structured outputs that I also highly recommend reading up on. I think it's one of the most powerful things, JSON mode and structured outputs, if you're using a model like GPT-4o or OpenAI's models that are compatible with function tool calling. And so that essentially is what is going on over here. Over here, same thing for search Bing grounding. So over here, perform a public web search for real time using Bing grounding. For example, I went ahead and gave it just a little bit of examples, but here's like the types of things. I mentioned the FDA because that was something I heard from the business. FDA, new hyperlipidemia drugs, recent hypertension. These are actually real things the cardiologist would go and query. And then here's my lookup patient data function. Okay, so I have a description over here. Here is like the query to Azure SQL table. And then here, what I'm doing is I'm injecting my table schema. Okay, and so inside of this table schema, you see all the different fields and table names and types and all that good stuff. Okay. Now, this is a really good scenario for, maybe a single SQL database, but imagine a world, where you're a large enterprise and you have thousands of different, tables or views. And so, should I create 1,000 different tools? Probably not. It's probably overkill and no one wants to do all that. And so one potential optimization lever that you could do is if you do have more than one SQL tables, because I've had multiple people ask this already, is you could actually get crafty where you build a router to your SQL. And that router could actually be something like an Azure AI Search index, where I have a separate index other than my ACC guidelines here that could be called structured data SQL routing index. And so what is that going to contain? What is that going to contain? It could contain a high-level description of all these SQL tables, as well as the schemas. And I could vectorize the descriptions, maybe even the schemas if you really wanted to, probably just the descriptions, and maybe some metadata as well if you want to, get crafty with filtering. And then your agent can then have a tool that prior to calling this lookup patient data, or as part of this lookup patient data function, it will tool call AI search to go do a vector search to give me the top 3 most relevant schemas that I may need. And if it needs more than one, talk about the Agentic RAG system, it could go back and then do that. Hey, I already got some data from SQL table 1 that AI search returned for me. And it generated the natural language to SQL, got the right information. Awesome. Now I need to go back and do another SQL table lookup. And so that's like, I'm not going to show that here. I'm just going to show a more simple example, but that's one approach of if you have a very large corpus of structured data that you want your agent to leverage. Okay. In this case, I am going to now map the tool names to these actual functions. I am now going to define a system prompt, and believe it or not, I actually spent more time on these tool descriptions and prompts than I actually did writing this code. And, with a little help from GitHub Copilot. And that actually just shows like the iterative nature of building agents and why it's so important to evaluate and observe and test your AI agent systems. Okay. And so now we want to implement the multi-step agent system. Okay. So there's a lot of code here, but I'm going to simplify it as much as possible. So when you run this, this multi-agent system, what are the args? It's taking in a user query, and you'll notice this max steps here. Okay, why do we need max steps? Because in an agentic RAG system, potentially, depending upon how you prompt your agent, you can get yourself stuck in potentially infinite loop or consume a lot of tokens. And so what I'm doing inside of this function is I'm specifically saying, hey, I want you to for each of the agent calls, every time I hit enter on a query, I want you to only go through 3 steps for each tool call. Okay, no more. If you don't get the information you need, or if you get an error, whatever, give up and throw an error and saying you couldn't help me with this task. Okay, so there's performance reasons why I'm doing it, there's cost reasons why I'm doing that, and also just for demo reasons why I'm doing that. Okay, but just another kind of agentic RAG kind of property per se inside of this space to consider. And so what I'm doing over here, you can see here, I'm starting my first step, which is going ahead and making a call to Azure OpenAI chat completions, where you see here, I just have GPT-4o. I have passing in tools choice and tools choice auto. Again, if I were to refactor this, I would use the Azure AI agent service. I have another example as well, more lightweight example, not doing federation, but highly recommend using Azure AI agent service for doing all your tool calling and building your AI agent service instead of the chat completions. It's the Microsoft preferred approach, but for demo purposes, just going to show this. And then here, I'm just going to check the responses of each of my tool calls. So what I'm doing over here is I'm going ahead and appending the responses from each of these tool calls into messages. And so this is essentially my way of doing the tool calls. Here's just some, handling for how I'm actually looping through each of these tool calls, doing some error handling as well. Because again, you're calling a bunch of different tools. I probably should have used like Pydantic or something over here for even more better type safety, calling the appropriate tool over here, and so on. And so there's just a lot of different error handling that you'd probably want to do in this very custom approach. If you use something like Azure AI Agent Service on the server side, they'll have a lot more optimization most likely here. So okay, so with that, instead of showing these sample queries, I'm going to actually show this live in action, okay? So I have a chainlet app here, which essentially inside of this repo, I have a app.py file, which essentially I took that Jupyter notebook and just refactored it into a chainlet app. If you don't know what chainlet is, highly recommend it for demoing POCs of RAG applications, agents, and so on. So the first example I'm going to show here is, and this is running locally. I just did a quick command over here for running the chainlet app, just making sure it's still running. Cool. So I'm going to click this first query that I have over here. Wow, okay, that was really fast. How many patients have hypertension and are prescribed lisinopril? Okay. And so what happened over here, if you remember my code, I have a stepper function over here that says use natural language to SQL tool, which essentially is that look up patient data. And it is literally writing this natural language to SQL query for me. And I'm not going to go through my Azure SQL database, but this is exactly the answer I was looking for, 1071. And so that's an example of showcasing the natural language to SQL tool. So I have an agent call my Azure SQL database and do SQL writing for me. And that was a reasonably complex query, not the most hard, but also not the most simple. So now I want to show how live Bing web search works. So what if I wanted to ask something like, hey, something very recent, right? My agent has that pre-trained knowledge cutoff, right? So what if I said, are there any recent updates in 2025 on new anticoagulant therapies from the FDA? Okay, so this is just one way to test, live web search. I probably could even put today's date. But in this case, my tool is tool calling Azure AI Agent Service that just has a single tool, which is Bing web grounding. So is that the most clean approach? Again, probably not. But in this case, it gets the job done. Okay, so you can see over here, inside of this function args, it went ahead and did the concept of query rewriting based upon the description that I had in my tool that says recent updates, FDA new anticoagulant therapies. And here you can see my output. You could even see I'm getting some source citations back over here. Okay. And this is what the agent response is getting back to me. So pretty cool. Okay. And so next up, I want to show the retrieval from Azure AI Search. Okay. And so in this case, I'm specifically going to ask, what does the ACC, or American College of Cardiology, recommend as first-line therapy for hypertension in elderly patients? Okay, so as you can see over here, you can see the query rewrite happening over here from this initial query. This is doing a vector search to Azure AI Search, and I actually parsed using a markdown mode in AI Search. You can see everything's being rendered in markdown here. Yeah, it's a lot of documents, and here we go. So you can see my answer that's well grounded inside of these cited documents coming back from AI Search. First line agents, thiazide drugs, combination therapy, and so on. So now I just powered knowledge to my cardiologists here with data coming directly from American College of Cardiology in natural language. So I didn't have to go manually control F a bunch of PDFs, right? And so now let's go to, this is actually a real world scenario. So what if someone wanted to do an agentic RAG search? Or in other words, from a business perspective, what if the cardiologist here had a scenario, like I mentioned earlier, where there's a real patient, she has real medical history, she wants to have the best possible chance of living or curing her disease, in this case, hyperlipidemia. And in this case, the cardiologist wants in the best possible advice using all the different tools at his disposal to give the best possible advice. So in this case, imagine I'm the cardiologist. I have a 79-year-old patient named Gloria Paul with hyperlipidemia. She's on atorvastatin. I wish I could pronounce some of these. Can you confirm her medical details from the database, check the ACC guidelines for hyperlipidemia, and see if there are any new medication updates from the FDA as of February 2025. It's April, but that's okay. Then give me a summary, okay? And so in this case, you can see the first tool. What is it doing? It's finding information from the patient medical data table called Gloria Paul. First name equals Gloria, last name equals Paul, date of birth, 1940. Cool. Okay. And so in this case, it doesn't find anything. So my SQL tool kind of screwed up. Okay. Where I couldn't find anything on Gloria Paul. So maybe we can try this again. In this case, Azure AI Search knowledge retrieval tool. It does a query for hyperlipidemia. And then in this case, I also searched my Bing web grounding tool for, where is it? I think it was the second one. It's for live FDA updates. But what I'm going to do is I'm actually going to rerun this because I want Gloria Paul to be found successfully in my natural language to SQL tool. Okay, there we go. So in this case, my SQL query writing did a good job. So this is where you always have to be careful, okay? Because you can saw in the last one in my select statement, it was trying to give some date of birth. And so in this case, it actually kind of did the math right, where it said is 79 years old, and it tried to work math and actually do an and clause on the date of birth. But in this case, we didn't need to do that. We just wanted it to do first name equals Gloria and last name equals Paul, and we get her information over here. Okay, cool. And again, this is all fictional. Here's my AI search retrieval tool. Here's the data that I'm getting back from AI search. Here is my Bing web search results in February 2025, made several updates. Bavarian Nordics, vaccine, so on, so on. And so what do I want to now send to my patient? Patient name, Gloria Paul, medical condition, a nice bulleted list summary here to just recap everything. Here's the ACC guidelines. Here, where I, as a cardiologist, I'm getting my knowledge from my knowledge tools at my disposal. I want to do the web search to see if there's anything as a very recent, maybe that I can provide options for Gloria over here. And then what do I want to actually send to an email or give her at checkout? Here's the summary. Diagnosed, here's what she's treated, here's the latest guidelines of what we could possibly do. And of course, you could even get even further and personalize this as a cardiologist, or maybe do a follow-up phone call and use this as a reference. And so this is just one real-world scenario of how Agentic RAG can actually be used in action to really solve real-world pain points. And that's what I want to spend most of today's Agent Hack with you, showing how this is all possible and the tools available inside of Azure AI Foundry and different frameworks and tools and coding languages you could use to actually create some of this. So to wrap up, other repos I just want to show you, so you can find most of all these code samples just on my personal GitHub repo at Azure AI Agents Playground. I talked about some other Agentic RAG strategies. If you want to read a more kind of in-depth blog, you can also go ahead and visit my hashnode.dev, where you can read exactly how I went through this step-by-step and so on, with some commentary. If you are interested in other industries, I also have some blogs on using semantic kernel for insurance claims. If you're in the legal business, how you can use frameworks like Llama Index and Crew AI with Azure AI services, if you're a fan of those frameworks for building an agent system and so on. So, and again, if you want to get your hands dirty with memory, highly recommend looking into MemZero. I think it's a great open source framework as well. And then lastly, MCP has been a very hot topic. I already saw some questions in the chat about it. Here's just a very, very lightweight example. If you go to Azure AI Foundry, here's a very, very lightweight, I'm not even calling it the official one, just a sample to show how you can build an MCP server with Azure AI Azure AI Agent Service. And so with that, I thank everyone. I hope you learned something about Agentic RAG, if not mastering it, and happy to be here and enjoy hacking. Thank you.
Hi, everyone. Hope you enjoyed today's session. If you aren't registered for the AI Agents Hackathon yet, register now at aka.ms/agentshack and start hacking on the agent of your dreams.
And if you have any questions along the way, just post in our GitHub discussion forum or attend our live office hours in Discord. And of course, make sure that you keep attending the live streams to keep learning about agents.
Once your project is ready, submit it before April 30th at 11:59 p.m. PT to be eligible for our prizes. Thanks for joining.